Hello, this is Todd Summers, Director of Research and Development for SoftWrite. We are proud to present the Reflections module for TAP 7.5, which is a significant expansion over the legacy TAP 6 capability. You will find that if you open a path study, you now see the Reflections tab under the Fixed Facility TX pane. If you click the Reflections tab, the first time you click it, it'll bring in all the information from your Fixed Facility TX and Fixed Facility RX, and under Study Setup, your transmitter 1 and receiver 1 will be populated with those parameters. Go under transmitter 1, you'll see the name, TX frequency, antenna height. These all can be adjusted as you wish, so you can do iterative calculations. It also brings in your antenna pattern as well if you have one defined. This one does not actually have one defined, so we can click Open. In this case, we'll go to microwave parabolic. We'll click this one, click OK. Now it's important to note with some microwave patterns that often the elevation pattern is not included. So if you check this checkbox here, it'll use the azimuth pattern for the missing elevation pattern as well. Now under antenna mounting, it'll suck in all your orientation information here if you have it defined. If not, you can also check always point at RX1 or RX2 if you have a second receiver antenna. You can check this. Now, if you make any changes, if you go and click back here to Fixed Facility TX, make any changes here, change the facility, when you go back to Reflections, if you want to load in that change, you'll just click Load for Facilities up here. And once you've made changes over here, if you made any changes and these are not the locked demo facilities, you can click Copy to Facilities to copy those entries back, like antenna height, frequency, antenna pattern, so on. For receiver 1, it's going to bring in your antenna height, and same thing, you can also open antenna pattern here as well. We'll click the same one, solid parabolic. Okay. Now I have antenna pattern, we'll point it directly at TX1, so we can do calculation of antenna discrimination if we wish. Now, if I use diversity transmitter, you'll see a transmitter 2 pops up here, and I can put in second transmitter, different height, different frequency. So you can evaluate spatial diversity, frequency diversity, advantages, for instance. Doing that, I'll take this off for now. Same thing if I do use diversity receiver, I'll add a receiver 2 expandable down here. For now, we'll just do single transmitter, single receiver. Under reflection coefficient, you could set a fixed value reflection coefficient. With TAP 6, you just use 1 for all values. If you wish to, you could change this to say 0.9 or 0.8, whatever you want to use. If you have the land cover module, you could select use land cover data, and then you can set the coefficient as a function of the land cover that you land on. So if you want developed open space to be lower than, say, open water, if you want, say, forest, deciduous forest, evergreen to be much lower values, you can do that as well. That is up to you how you define those. For now, we just set those as all ones. Once you have that set, you can click Save Study Defaults to retain that information for use later on. Otherwise, the information is not saved. Down below, under Static Analysis, you have a curvature dropdown. With TAP 6, it would search over all topo points and determine for every topo point, any points, find all points for which the Earth curvature was between which the reflection had an Earth curvature between 2/3 and 4/3. You had the potential in that case that if you had too coarse of a topo step, you could actually miss reflections. In TAP 7, it allows you to set a K minimum, K maximum, and search over the user-defined range. This is capped from 0 to 1,000, 0.5 to 1.5. It's kind of a larger range, but we include it as that. So if you want to go back to the traditional TAP 6 way, you can put in 2/3 and 4/3 here as your range of curvatures. You also have the option, if you'd like to do specific curvature values. You can add to this list. This right now is 0.667 and 4/3, so 2/3 and 4/3. If you want to add one, just click Add. To bring it off the list, click here to subtract this. If you want a specific curvature values to evaluate, you can click there. For a range of curvatures, what TAP will do is it'll search both topo points and the interpolated areas between all topo points. So it does a full search. It finds all points associated with this K minimum value, all points where you have this K maximum value, whether that point is at topo data points or in between those. It also evaluates all topo points similar to TAP6 and finds which ones have reflections with K values that are between or in this range. Now, there's a third step. It actually runs back through the range of reflections and finds all potential local minima. So between the topo points, if there are points where you can have even Fresnel zones impacting the ground, it finds the reflection points and their respective curvatures and includes those in the list as well. So you get 3 sets of outputs when you run with range of curvatures. And I'll show you that here briefly. Down under here, you click the Run button, and you'll notice that what pops up here, you get a bunch of like brown circles on the axis here, and then yellow suggests whichever one is highlighted. Automatically, it's going to find the one with the worst case over all that were found. So for each reflection, you have the transmitter and receiver. Now, if you've got, the reason why this matters is in case you have diversity transmitter, diversity receiver active. That'll matter. You'll want to group by those potentially. This shows the distance, the elevation at the reflection point, the curvature corresponding to that reflection point, whether the line of sight is clear from the transmitter to the reflection point. RxLOS is whether the line of sight is clear from the reflection point to the receiver. You have the Fresnel number for that reflection. In this case, you'll notice that is an even Fresnel, which gives us the worst case, as expected. You have the phase for that one, almost 180 degrees. You have the reflection coefficient here. So if you had a reflection coefficient defined as a function of land cover data, you might see different values here. As it stands, I set it as 1, so reflection coefficient is 1 over all of these reflections. So it's kind of a worst case assessment. Your antenna discrimination is the difference in the antenna gain between your direct signal and your reflected signal as a function from the transmitter's view. And the RX antenna discrimination is the difference between the between the direct signal and the received signal from the receiver's point of view. So in this case, you got 18 on this side, 12 on this side. And the sum is, in dB, is the effect on your total signal. Now, in this case, you have significant antenna discrimination, transmitter and receiver antenna discrimination. So the sum is fairly low. Now, if I go to the very top of the list here, you'll notice that I have 3 curvatures in here, 3 sets here. You have the curvature of 0.5. This is one of my endpoints. If I go down to the very bottom is my 1.5, which is the other endpoint. Within this set of values, you also have ones that are at discrete distances. So I've run this at 100-meter steps. So you'll see there's one at 25.8 kilometers, which has a Fresnel, which is not exactly an even Fresnel zone. You have it at 25.9. You'll have it at 26. 26.1, and then the values in between these topo points are the ones associated with the local nulls, so our local minima. These are even Fresnel zones where they impact the ground, so they could potentially give you worst case values. When you have this full set, if you want to go back to the original view, you can click up here and click Draw Profile. That resets. Click Run again to repopulate. It runs fairly quickly, so you can just click Run. It'll come back. You have, if you want to hide block paths, you can click here. In this case, it hides all because they're all blocked. You can click Hide Crosslinks. This will hide TX1 to RX2 and RX1 to TX2. So in the case you want to hide those, click that. And then if you want to include the full list of all outputs in your report, when you click Generate Report, it'll show the full list when you generate the report. This Generate Report will show a view of that reflection that you have selected, the information about that selected reflection, the study setup, site/path information down here, the range over which you have potential reflections, in this case 25.74 kilometers to 26.42 kilometers. And then down here, since I had the reflection list active, it shows my reflection list. These are my these are the points, these are my endpoints, so the 0.5, the 1.5, and then all topo points in between go in this table here. And then the second table is all the local minima that I found, the phases for these, which are all going to be pretty close to 180 degrees, since they're all even Fresnel zones. And that's that report. If you'd like to do a different report, you can go up here and select Generate Report. And we now have, with 7.5, there's now a landscape template _75 reflection.html. And it fills in the reflection components. You'll notice that in the template setup, there is, you can add more, you can add the reflection outputs in there as well. So I need to go and redo my logo here, but you have all the information to transmit, receive, the path itself, and then here's this. So you get the view of the reflected signal in here. Then you can work off of this. Under Template Editor, you'll notice there's new reflection fields that you can add. You go into Profile, Reflections. You have Transmitter. If you want to create a template, you go to find transmitter values for that reflection, receiver values for that reflection, and then also the reflection values for that particular one you have selected, the coefficient, distance, elevation, Fresnel number, K, phase, slant angle, and sum. The sum dB being the overall impact on your signal. And those transmitter receive values are what's taken out of the transmitter 1, receiver 1, and shown here as well. You can also click on Generate CSV down here. To generate a CSV value, you just get popped up a window dialog to save a file. Then you can save it. If you wish to include surface features, you can add surface features. So we'll click Add. We'll create a new one. Let's call it Test 2. Open. And I'll add a feature here, just as demonstration. Add feature. And make the height, make it very tall, not realistic. But click Use Surface Features, and these surface features will be included. So whereas previously I had clear line of sight from the transmitter down here, you'll notice here that I've made this so that it actually blocks the line of sight. So if your line of sight is blocked either by terrain or surface features, this run, the run button will be inactive. So one or more TX paths are blocked. That'll be the signal that you get. If I go back in here and I make it a little shorter, so it is not blocking. Again, this is not realistic. I'm just using this as an example. And I run, it'll show TXLOX. TXLOS, which is previously clear for all these, is now blocked. So blocked in the output. When everything's squared away and everything, I like everything that I have in here, you can click Copy to Facilities after I've done manipulating here, getting the values out that I like and adjusting things. And that's it. That is the new Reflections module. We're very excited about it. A lot of new capabilities in there, and you'll find, hopefully, that you should really enjoy it. Thank you for your time. Have a great day.